Not so sure about this. We'll try it though. So, properties of parallelograms. If we look at this opening exercise, we have two triangles here. And the first question says, if the triangles are congruent, state the congruence. What we know here is I have two parallel lines and a transversal. So we have an angle here congruent to another angle. You see we have angle J congruent to angle T. So we do know that these triangles are congruent because of angle, side. So let's go ahead and state the congruence. Oh, awesome. Sorry about that. I have triangle AGT is congruent to triangle MYJ. Remember, we have to do it in the right order, so we went across the single tick to the 90 degree to the single arc. Single tick, 90 degree, single arc. So we named them in the right order. What triangle congruence criteria did we use? We used angle, side. Angle, side, angle, side. And segment TG corresponds with segment JY. Okay, let's look at this discussion. How can we use our knowledge of triangle congruence criteria to establish other geometry facts? For instance, what can we now prove about the properties of a parallelogram? To date, we have defined the parallelogram to be a quadrilateral, which means 4 sides, in which both pairs of opposite sides are parallel. However, we have assumed other details about parallelograms to be true. We assume that opposite sides are congruent, opposite angles are congruent, and diagonals bisect each other. Let's examine why each of these properties is true. Okay, we have example 1. Okay, you have this example in front of you. I have a blank sheet of paper. If a quadrilateral is a parallelogram, then its opposite sides and angles are equal in measure. Complete the diagram and develop an appropriate given and prove for this case. Use triangle congruence criteria to demonstrate why opposite sides and angles of a parallelogram are congruent. So first of all, given. I'll move my hand in a second. I'm saying it out loud too if you want to follow along. Parallelogram ABCD. We have AB is parallel to CD, and AD is parallel to CB. We are trying to prove that AD is equal to CB, AB is equal to CD, the measure of angle A is equal to the measure of angle C, and the measure of angle B is equal to the measure of angle D. So let's label the quadrilateral A, B, C, D. Notice we usually start in a corner and go clockwise, and then mark the opposite sides as parallel. So we have parallel and parallel. And then draw a diagonal BD. Let me find my ruler. So we have a diagonal. All right, so let's go through the proof. So we're trying to prove that AD equals CB, AB equals CD, and then the measure of angle A equals measure of angle C, measure of angle B equals measure of angle D. So our given part, we know this is a parallelogram. ABCD, ABCD, and that is in fact given. We also know that the measure of angle ABD is equal to CDB. We have alternate interior angles. Let me mark that. ABD, CDB. So the measure of angle ABD is equal to the measure of angle CDB because of alternate interior angles. And we can also say that the center is equal to the center. BD is equal to DB, and that is reflexive. Okay, we can do the other parallel lines. So that is congruent to that. We can say that angle CBD, yep, is equal to the measure of angle ADB, and they are alternate interior. Now I've got two congruent triangles, which is very exciting. So triangle, name them in the right order. I'm going to go double arc, side, single arc. DBA is congruent to triangle, double arc, side, single arc. BDC because of angle, side, angle. Awesome. Okay, this is usually when I go back to the beginning and try to remember what exactly I'm doing. We're trying to prove that AD is equal to CB, AB is equal to CD, and the measure of the angles are congruent. Well, looking at this last congruency, I've got BA, so AB is congruent to DC, which is right here. Let me get another color to show you, because remember, corresponding sides are in the right order. So CD, this is what we're trying to prove, is congruent to AB. CD congruent to AB, and then AD congruent to BC. So that's beginning and end is congruent to beginning and end. So I can say that part. AD is equal to CB and AB is equal to CD because congruent parts of congruent triangles are congruent. Cool. I could also say angle A is congruent to angle C. For the same reason. If I look, angle A is last in the naming and angle C is last in the naming too. So that's awesome. Now I'm trying to get to angle B and angle D, which is going to take a little bit more work. Luckily I can say, I'm going to number these. 1, 2, 3, 4. So angle D, I shouldn't do that. I want to just name an angle D because that's what I'm looking for right here. But angle, let's see, ADC is equal to angle 1 plus angle 2. And angle CBA is equal to angle 3 plus angle 4. And that's just angle addition. Cool. Okay, so if we know that angle 1 is congruent to 3 and angle 4 is congruent to angle 2, we can do a little bit of conniving here at the end to get that everything is equal to each other. So let's do some addition. I have angle ADB, so angle 1 plus CDB. Angle 2 is equal to CBD, 3 plus angle 4. Our reasoning here is just the addition property of equality. Angle 1 plus angle 2 equals angle 3 plus angle 4. And if we go back up here, we know that we have angle 1 and angle 2 equal to each other, and angle 3 and angle 1 and 3 and angle 2 and 4 equal to each other. So 1 is equal to 3 and 2 is equal to 4. So we are at the end, measure of angle B equals the measure of angle D, just because of substitution. We've already said that those things are equal. So 1 plus 2 is equal to 3 plus 4, so they are equal to each other. And that was the end. Good job. That was example 1. We have quite a few more to go. Okay, let's try example 2. If a quadrilateral is a parallelogram, then the diagonals bisect each other. Complete the diagram and develop an appropriate given and proof for this case. Use triangle congruence criteria to demonstrate why diagonals of a parallelogram bisect each other. Remember, now that we have proved opposite sides and angles of a parallelogram to be congruent, we are free to use these facts as needed. Actually, that's what we're doing today. We're trying to prove a bunch of stuff about a parallelogram that we can then use to prove other things. Okay? So let's label the quadrilateral ABCD. And mark opposite sides as parallel. Oh, I missed. And I'm in a Sharpie, can't erase. And then we're going to go ahead and construct two diagonals, because we're going to prove that they bisect each other. This is a very common proof for triangles using a parallelogram and bisections, because we've got vertical angles, we have sides that are congruent, etc. So let's go through it. I have parallelogram ABCD, and that is given. Now we know that these angles are equal. Let's go ahead and label that the sides are equal, because that is an easy one. I've got AB is equal to CD, opposite sides of a parallelogram are equal. Cool. Now, let's look at some of the angles. We have parallel lines. So if I've got angle 1, it's going to be congruent to which angle? Way down here, angle 2. Because parallel lines cut by transversal, the alternate interior angles are congruent. So angle 1 is equal to angle 2 because of alternate interior angles. Okay, now let's look at some vertical angles. I didn't label the inside. Let's label this E. So we have A, B, C, D, and E. So AEB, let's number this 3, is going to be congruent to CED. So angle 3 is equal to angle 4 because they are vertical. Vertical angles are equal in measure. Okay, and we know that AB equals CD. I didn't mark that. So those are congruent, and those are congruent. Looks like I have two congruent triangles. AEB is congruent to triangle CED because of angle, angle, side. And here we're trying to prove that diagonals bisect each other. So if we marked, let me get my colored pencil. If we marked this triangle congruent to this triangle, we know that corresponding sides are congruent. They bisect each other, which means they cut them in equal pieces. So let's go ahead and write that down. AE is equal to EC, and BE is equal to ED because of corresponding parts of congruent triangles are congruent. And that's what we were trying to prove, that diagonals bisect each other. That one wasn't too bad. Example 2, done. So we've talked quite a bit about why the properties of parallelograms that we've assumed to be true are really true, because we've just proven them true. Now we're going to extend these facts into a special parallelograms like rectangles, squares, and rhombuses. So let's look at a rectangle now. Example 3 says, if the parallelogram is a rectangle, then the diagonals are equal in length. Complete the diagram and develop an appropriate given and proof for this case. Use triangle congruence criteria to demonstrate why diagonals of a rectangle are congruent. So we can use information that we've already proven in this case too. From example 1 and example 2, we can use that information. So let me write down what we're proving. So given is rectangle G, H, I, and J. We are trying to prove that diagonals are equal in length. So I'm going to draw some diagonals. So G, H, I, and J. Draw some diagonals. So I've labeled my rectangle and I've drawn my diagonals. We know that opposite sides are parallel, and we also know that opposite sides are congruent, correct? So we have rectangle G, H, I, and J. That is in fact given, and we know that GJ equals IH, GJ equals IH, and GH equals JI. GH. Okay, those are both opposite sides of a parallelogram are equal. And we know that GH is parallel to JI and GJ is parallel to HI. Definition of parallelogram. I actually don't think we have to say that anymore, but it's there, it's given. Okay, it's all part of the problem. All right, so GJ is equal to IH. And let's go ahead and go to GH is equal to HG. Because these are the triangles I'm working with. I'm going for this one because I need the whole diagonal. Let me grab another colored pencil. And this one. So you see how they're sort of overlapping? If I just sketch it really basically, that one and, oh, for goodness sakes, that was a bad idea, especially in Sharpie. So here I have H, G, I, and G, J, H. So we marked this double tick, single tick, and then next I'm going to say that these are both right angles and therefore congruent. I need to name them with 3 letters though. G. Sorry, my alarm went off. I just did JGH, and IHG is equal to angle IHG is equal to 90 degrees because it's a rectangle. Definition of rectangle. All the angles are going to be 90 degrees. So now we know that the triangles are congruent. Triangle GHJ is congruent to triangle HGI because of side angle side. And once you know the triangles are congruent, you can say the third sides are congruent. So GI is equal to JH, because congruent parts of congruent triangles are in fact congruent. Okay. Very fun. Sorry about that drawing up there. If you have any questions, I will explain tomorrow. All right, example 4, almost done. Okay, here we have if both pairs of, now we're going to look at converse properties. Now we examine the converse of each of the properties we proved. So we did 1, 2, 3. Now we're going to go the backwards way in 4, 5, 6. So begin with a property and prove that the quadrilateral is in fact a parallelogram. So let's look at this first one. For my given, I have quadrilateral ABCD with the measure of angle A is equal to the measure of angle C, and the measure of angle B is equal to the measure of angle D. So let's label it ABCD. What are we trying to prove? We're trying to prove that quadrilateral ABCD is in fact a parallelogram. So I've labeled them. I'm going to go ahead and draw a diagonal, just like we did the first time. Okay, we mark that angle A is congruent to angle C, and we know that angle B is congruent to angle D. I'm going to go ahead and throw some letters in here to help us a little bit. Let's do that as X, and we know that's X also because they are congruent, they're equal. And let's go R, S, T, and U, just so we can talk about them just a little bit easier. Okay, so we have all of our givens and what we're trying to prove. I should write it out like I make you guys write it out. So quadrilateral ABCD is given, and the measure of angle A equals the measure of angle C equals the measure of angle D. This is all given. Okay, all right, let's talk about those other angles, D and B. So the measure of angle D is equal to R plus S, and the measure of angle B is equal to T plus. Okay, that last video stopped at a very awkward spot, so I redrew half of it, and I think we're good. I hope I can edit it together so that it makes sense. So we are trying to prove that quadrilateral ABCD is a parallelogram, and we know that these two angles are congruent. We're trying to get that R, S, T, and U, those will be congruent. So we know that the big angle is congruent. Trying to get to, if we can get T and S congruent and U and R congruent, then we know alternate interior angles means that those opposite sides are parallel, which is the definition of a parallelogram. So we're going to do some magic with some angles and just try to follow along. So we have R plus S equals T plus U. We're going to go ahead and subtract R plus T. Wait a minute. Oh, no. Sorry. We're going to add all of those angles together. X plus R plus T is the inside of this triangle. X plus R plus T, that's going to be equal to this triangle because they're both 180. The inside of a triangle always equals 180. X plus S plus U equals 180. And that's just the angles inside a triangle sum to 180 degrees. Now we can go ahead and subtract X from both sides. R plus T equals S plus U. I keep doing that, writing SU. I don't know why, something in my head. And that's just the subtraction property. Then we're going to take R plus T and subtract R plus S. r plus t, subtract r plus s, s plus u, subtract t plus u. Those have to be in parentheses because I've got a subtraction outside of parentheses, which means I have to distribute that. If we distribute that, the r's cancel and I'm left with t minus s equals s. Here the u's cancel, s minus t. I'll get my reasons written over there in just 1 second. Let's follow this train of thought. T minus s plus s minus t equals s minus t plus s minus t, just addition property of equality. I'm adding something to both sides. I know it seems sort of strange right now, but try to follow along. Okay, this is the additive property of equality. It's like from your algebra days. And then subtraction property of equality. I just subtracted something from both sides. Okay, so let's follow our math here. T minus t cancels out. Negative s plus s cancels out. I've got 0 on one side. S plus s. Two times s minus t. I just did some addition and subtraction. And I divide both sides by 2, still left with 0 equals s minus t, which really means t equals s. This is division. And then addition. Phew, that was rough, wasn't it? S equals t, therefore equals r, therefore equals u. Because of substitution. I just proved that everything is equal to everything. Substitution. And if s is equal to t and r is equal to u, it's not. Those are alternate interior, therefore we know that AB is parallel to DC and AD is parallel to BC. This is alternate interior angles are equal, therefore lines are parallel. So now we know that quadrilateral ABCD is a parallelogram because we know the definition of a parallelogram. That was a long one. Okay, let's hope this next one's a bit easier. Okay, we're doing converses, remember? All right, so here we have given quadrilateral ABCD with AB is equal to CD and AD is equal to BC. A, B, C, D. We just did this and that. Oops, single tick. Can't erase it, sorry. Constructor diagonal. And we're trying to prove that quadrilateral ABCD is a parallelogram. So we know, let's write down our givens. We have quadrilateral ABCD. We have AB is equal to CD and AD is equal to BC. Those are all given. Okay, let's do this side. DC, nope. DB is equal to BD because it's reflexive. And now we know the triangles are congruent. Because of what? Side, side, side. Now we can say all the angles are congruent, right? let's number them. 1, 2, 3, 4. Okay, A, B, D. So we have angle 1 is congruent to CDB angle 3, and angle 2 is congruent to angle 4 because of CPCTC. So we have angle ABD. ABD is congruent to CDB. So corresponding parts of congruent triangles are congruent. So therefore we know that AB is parallel to CD and AD is parallel to CB. Because if alternate interior angles are equal, the lines are parallel. That was easier, wasn't it? So therefore quadrilateral ABCD is in fact a parallelogram. I shouldn't do that. Parallelogram. Hey guys, only one more. Anyone else excited? Oh no, I think one more. I have an extra, oh there's 7. Oh, for goodness sakes. Okay. So here, quadrilateral ABCD, diagonals AC and BD bisect each other. So if we know that, then we're trying to prove that quadrilateral ABCD is a parallelogram. So let's label everything A, B, C, D. 2 diagonals. Oh, there was my finger there in the middle. That's awesome. We know that these are congruent and those are congruent. All right, so quadrilateral ABCD is given, and AC and BD bisect each other. This is all, in fact, given. So now we can say that AE equals EC and BE equals ED. Definition of segment bisector. We have all of our vertical angles. I'm going to number them 1, 2, 3, 4. So angle 1 is equal, measure of angle 1 is equal to the measure of angle 2. And the measure of angle 3 is equal to the measure of angle 4 because they are vertical angles. So now I can say side angle side, side angle side. I actually have 4 triangles that are congruent to each other, right? These 2 for side angle side, and those 2 for side angle side. So triangle DEC is congruent to triangle BEA, and triangle AED is congruent to triangle CEB, side angle side. Therefore we can say ABD, that these are congruent and those are congruent. And once we say that, we know that the lines are parallel. 1, 2, 3, 4, 5, 6, 7, 8. Getting a little lazy, right? Measure of angle 5 is equal to the measure of angle 6. And the measure of angle 7 is equal to the measure of angle 8. because of CPCTC. Therefore, AB is parallel to DC and AD is parallel to CB. When alternate interior angles are equal, the lines are parallel. So we know quadrilateral A, B, C, D is a parallelogram because of the definition of parallelogram. Yay! One more. Let's talk about that rectangle. Okay, it's the last one. So, if the diagonals of a parallelogram are equal in length, then the parallelogram is a rectangle. Complete the diagram and give an appropriate given and proof for this case. So, given parallelogram GHIJ with diagonals GI equals HJ. We're trying to prove that GHIJ is a rectangle. So let's label it GHIJ and construct our diagonals. All right. Okay, so let's go through the proof. We know that parallelogram GHIJ, and we know that GI equals HJ. Those are both given. Okay, we also know that GJ equals HI. Nope, that's not what I'm going for. We know that, sorry,